Folks, this is our first video of mathematics on our doubt solving channel. So this question is related to vectors. The question I hope is on your screen. It says if vector I cap plus 2j cap plus 2k cap is rotated through the angle of 90 degree so as to cross the positive direction of y-axis in the vector in the new position is, and you've got four options. Now here I would want you to note this very crucial information that the vector crosses the positive direction of y-axis. So let's try to analyze the vector. Let's draw the coordinate axis, which is something like this out here. So this is our x-axis, this is our z-axis, and this is our y-axis. Now I think this is not a kind of coordinate axis system you'd usually see, but to make this problem clear I've used this form. So we have the initial vector in, let's say, somewhat this direction. So this point is 1, so this is our I cap plus 2j cap plus 2k cap, and we're rotating this vector by an angle 90 degrees. So it is a three-dimensional coordinate system, and there are various ways we can rotate this vector. We can rotate it in sort of this kind of fashion so that it makes angle 90 degree, and we can do it similarly here so that it makes angle 90 degree. So we can have different versions of these vectors. We can also rotate it here, making an angle 90 degree. But what is said here is that the vector crosses the positive direction of y-axis, which means that I rotate this vector, let's have the arrow here, I rotate the vector in such a way that during its rotation, it exactly passes through the y-axis. That means at a point of rotation, we get an instant when the vector is collinear with the y-axis. That means I rotate the vector like this, I go there in this way, and at one instant when I rotate, so the final vector, let's say, is pointing towards this direction, making an angle of 90 degrees. So during the process of rotation, the vector was passing through the y-axis. So what I intend to say, and then I think this is very unclear, so let's have this cross section drawn here again. So what I want to say is this was our original vector, and I rotate it by an angle 90 degree such that during the process of rotation it is exactly planar with the y-axis all the time, and at one instant you might find, so this is the process of rotation of the vector, so we're slowly rotating it from this direction to this direction. At one instant it is collinear with the y-axis. What I want to say is that this vector at the completion of the rotation is coplanar with y. So I think this information is very important for solving the problem. Now I think things will be very easy. So now let's start solving it. We're actually heading forward to solve the problem. So let's say we have this as our coordinate axis. As said, this is x, this is z, and this is y. Now we have the vector mentioned in the problem, which is I cap plus 2j cap plus 2k cap over here, and we rotate this vector by an angle 90 degrees such that the new vector is a vector a. We want to find this exact vector. What I want to say now, I think you've seen the figure, so let's head forward to the workspace. So I have got a vector a, and I assume it to be xi cap plus yj cap plus zk cap. Now since it's the original vector which I rotated, the magnitude of a is going to be equal to the magnitude of the vector taken initially. So the initial vector, I'm going to say that to be a initial, was I cap plus 2j cap plus 2k cap, and the magnitude of this vector, I believe, was 1 plus 4, that is, it was 3. That means the magnitude of a should be 3 as well, or we get that x square plus y square plus z square is equal to 9. So once we have this information now, So this is our first equation. Our second equation comes from that this vector, sorry, so this vector and this vector are perpendicular, so their dot product should be equal to 0. So this gives us that x plus 2y plus 2z is equal to 0. If solving the dot product here, we're getting this equation. Now, as I mentioned, that the final vector, let's have it again. So the vector a here is coplanar with the y-axis. So if we assume a random vector in a direction of y-axis, we can say that a and a random vector, let's say along the y-axis, any random vector, we will use a j cap. So these two vectors are coplanar. So the determinant of the vectors will be 0. So we will get a third equation. What we can say using the determinant is that our vectors j cap, which I took initially, our vector xyz, and our initial vector 1 2 2, the determinant yields 0. So we take the help of this 1, we find its cofactor. So what we get is minus 1 2x minus z is equal to 0, and what we are left with is that 2x is equal to z. So this serves as our third equation. So let's write the equations once more. So what we have is 2x is equal to z, x squared plus y squared plus z squared is equal to 9, and x plus 2y plus 2z is equal to 0. I hope I'm correct. So let's put the value of z over here. What we get is 5x plus 2y, I hope I'm correct, is equal to 0. So you're using this equation and the third equation to get this, which gives you again a ratio between x and y. So this can give us that 5x is equal to minus 2 of y, and if we do that, what we can say is that 5z by 2 is equal to 2y, that is z is equal to minus 4y by 5. So we are going to put each of z, x and y in a single variable, and we're going to say it's the variable z, and we're going to put that in this equation. So we're going to get, or let's use x, that will be better, I believe. So let's have this. So what we get is 2x squared, and the y also has to be represented in terms of x. So what we get is minus 5 by 2x squared. This should be equal to 9. So 5x squared plus 25x squared by 4 should be 9, which gives 45. I hope I'm correct. 45 by 4 is equal to 9. Therefore, I think it's not visible there. So yeah, this is it. And if we simplify this, what we get is x squared is equal to 4 by 5. So we can see the options. I think you can see in the figure above. We have 2 by root 5 and minus 2 by root 5. So we're not exactly sure which of them should be it. So let's say for now, x is plus minus 2 by root 5. Alright, so we have still z and we have to find y. So z should be, in terms of x, it should be plus minus 4 by root 5. And y should be, okay, so y is minus plus of 5 by 2, 2 by root 5, that is minus plus root 5. So what we have, okay, I think it's not visible. Okay, so what we now have is that the vector a required should be plus minus root 2 by root 5 minus plus this and plus minus 4 by root 5. Where have we got that? So it's only and only satisfied in option B. So it should be the correct answer.